there, my name's Ken. I am a pen tester with a particular interest in the Internet of Things. I spend most of my time looking at consumer devices, and the reason I do that is, frankly, you can go into the shop and buy them. You don't kill people if you break them, which is always helpful, and the manufacturers really don't seem to have much of a clue. It's really straightforward. I want to show you a few examples of some of the really simple ways we've found of getting into IoT devices and finding stuff that, frankly, you can all take away and do yourselves. Go and have a look, follow the simple tips and techniques I'll show you. Really basic stuff. It's unbelievable how straightforward this is. We're going to have some hot liquids in this and a fair bit of swearing as well, so if you're going to be offended by that, please leave now. I've got some really simple principles if you're writing a mobile app to drive a consumer IoT device. Number one, write it securely. We know how to write secure mobile apps. There's loads of guidance out there. OWASP, the Open Web Application Security Project, has got some fantastic guidance on how to write a well-secured mobile application. Secondly, then you might consider, as a defense in depth, another layer, you might consider obfuscating the code to make it difficult to reverse engineer, difficult to decompile, difficult for someone who's trying to hack it to follow how the code works. And in all the time I've been looking at these devices, I've never seen those two principles followed. Nuts, eh? So what's the problem? Where's it all come from? So from my perspective, looking at consumer devices, I think you've seen an enormous leap forward in the complexity that's required for manufacturers of, frankly, things. It used to be, we learned how to write good web applications. We learned how to secure our systems. We learned how to patch them. Great, fantastic. Now, all of a sudden, for a manufacturer of a thing who's gone, I want to sell more, and I'm going to internet enable it. You've got mobile apps to worry about, you've got your web apps, you've got your APIs to make your services secure, you've got the device itself. And the bit that everyone really kind of forgets about is you've actually given not only your source code, but also your hardware to your user. That's a real change for someone who messes around with stuff like this usually. So where am I going to start? I'm going to start with my Kettle. Some of you will have seen bits of this before, but I want to go into a lot more detail. This is my Kettle. It's an internet-enabled kettle. It's Wi-Fi enabled. Most people say, why? Do you have a Wi-Fi enabled kettle? And I think the idea is there's the mobile app that goes with this. And when you wake up in the morning, you roll over, grab the phone that's by your bed, right? And you press the button on it, and by the time you get to your kitchen, you've got a kettle full of boiling water, saving you what, 30 seconds of your life? I don't know. But hey, anyway, interesting idea, interesting principles. We had a bit of a look at this just over a year ago, and I want to show you some of the crazy, crazy things that we found. It just blows my mind. So how do you go about attacking a kettle? Well, there's a few ways. First of all, we read the manual. Secondly, you might think about a port scan. But we jumped straight to number 2 there and took it apart. And that's the inside. That is a VSD03 Wi-Fi module, which is there literally soldered onto the main board in order to offer Wi-Fi connectivity. It really has just bolted it on. That chip's worth a couple of bucks. That kettle's now 100 quid. Yeah, that's cool. I like this Internet of Things stuff. So we now know what we're dealing with. So what about going and finding some more information? So of course you go to my favorite hacking resource, which is of course Google, and there we find the manual, everything that we need. Excellent. OK. So I'm a bit stuck. I've got the manual now, but what am I going to do next? I know what I'm dealing with. Next place is to go for the mobile application. And I'm going to start with the Android app, primarily because it's a fair bit easier to work with. And over here, hopefully, I have got an example. So what I've done is I've pulled down an APK, so an Android package file. This one is for the Canary. You might have seen this advertised on the tube, little device that sits in your house and monitors it. I want to show you just how easy it is to reverse engineer a device. So I want to unpack it. I want to take the Android package. I want to turn it into a Java resource. Java, brilliant. I can read that. So the next thing to do is use a tool, something like JD GUI, or you can use JADX as well, pretty much of a muchness. And what I've got in here is the code that I've unpacked. So I'm now looking at it to see what's going on with this. And this is my Kettle. Now, what have I got in here? So hopefully up here somebody says, something useful. So it's in unconfigured mode at the moment. I haven't set up as a consumer. My mobile app needs to know how to talk to Kettle. So the first thing it's going to need to know is an IP address. And there you go. There's the IP address. Those of you who know networking, that's linked local, so that's a default situation. OK, great. So I set my IP address statically to the same range, and I can connect to it. So over here, hopefully, if it hasn't fallen over, great, I've got an interface. I'm now talking to my Kettle, but it's OK, it's got a password. What could possibly go wrong here? Another big clue up there. You see, AT. Hayes AT command set. Brilliant. It's like turning the clock back 30 or 40 years. Who remembers dial-up modems, AT, DT? Yep, great, you all remember this stuff. That's why I love the Internet of Things. It's like going backwards in terms of security. Password. OK, what's it going to take to find the password for an unconfigured Kettle? So I'm going to save a little bit of time here and just show you how straightforward this is. So AT commands. Let's have a look for stuff like this. There you go. There's the manual which discusses what the password is. And the command is AT plus pass, and the default system setting is 6 zeros. Get in. All right. 1, 2, 3, 4, 5, 6. There you go. I'm now talking Kettle. As you do. All right. Unconfigured Kettle nonetheless, though. OK, so it's going through its process. Now, what does it do next? I now need to look at following the code and see what I can extract from it. So I found a little earlier in this class was a bit more information for me. So there you go. This is where it starts. We're connecting with the Kettle for the first time. We need to authenticate to it, so we add 6 zeros. That's fine, nothing wrong with that. The next thing we do, AT plus WPRT, scan for wireless access points. That's what it says in the manual. Next thing, SSID. So look for the SSID you want to join, AT plus encryption, then define the encryption type, WPA, WPA2, or if you're crazy using WEP. Then here, AT plus key, set the Wi-Fi key, AT plus NIP, set the the internet address, turn the web server off. Yes, this Kettle does have a web server. AT plus pass, interesting, so that's supposed to change the password. AT plus Z, quit. AT plus PTMF, pass memory to flash, equivalent of save. So you save the configuration. So I can now do some stuff. So what about using some of those commands? The one I really was interested in was this one to start with, AT plus SSID. You can now recover the Kettle's SSID. Brilliant, but a little bit more interesting is go and look at this. I can now recover their pre-shared key. Now that's quite serious. So I can drive past the Kettle in someone's house. I can do a deauth attack, so I can deauthenticate it over Wi-Fi. I can then offer it a fake access point. It's got no profile validation, so it just connects to me based upon my SSID. Just have to have a higher power. I can then use the PIN. I can then pop in AT plus key, and I can recover your Wi-Fi key in plain text. And I think that's really, really scary. This is the bit that fails. Case 10 there is supposed to change the default PIN on your Kettle when you configure it for the first time. It's supposed to then change it to a 6-digit random number. Case 10 is never called by the code. Nuts. Utterly nuts. Now, the iOS version does successfully change that PIN. So we had a go at the iOS version and thought, hang on, 6 digits. So we connected to the Kettle, which had the PIN changed, had a go with the brute forcer. Hydra is a great example of that. And it took us less than 4 hours in order to attack the PIN and recover the user's pre-shared key. So you can drive past your house and steal your Wi-Fi key. If I've got your Wi-Fi key, what does that mean? Well, if you're crazy enough to have a Wi-Fi Kettle, I would wager that you haven't changed your router default admin password. Has anyone here done that? I sure have. Yeah, good for you. A few of you haven't. Great. Target for later. If you haven't changed your default router admin password, I'll use the default. I'm into it. I've then got control potentially over your DNS. I'll point your DNS somewhere else, to a malicious DNS service, one I've offered, so everything you try and type into a web browser resolves to me. Win. I've got stuff. OK, so we've got a Kettle. Now, there are other things you can do with this. Because it's a Wi-Fi device, you can do some quite cool stuff. You can write your own Python client to it and drive it from a desktop. So there's a guy called Mark Cox, who's awesome, who did a bit more on this. You can also then geolocate your Kettles, because it's a Wi-Fi device. People who go out doing war drives, stumbling attacks, upload them to websites like wiggle.net, W-I-G-L-E, fantastic, awesome resource. So you can locate the SSID of iKettle really easily. You can also, if someone's configured it, you can do lookups for the MAC address range that the Wi-Fi model sits on. But if someone hasn't configured their Kettle, you can drive past a house at any time of day and set their Kettle boiling. So they come home from work and their wallpaper's falling off the walls, the window's gone steamy, I don't know. What we really want to do, we're working on this is taking time, is to reverse engineer the controller that actually manages temperature and power. So there's potential to cause that to overheat. That'd be really interesting. Somebody said to me, Ken, you've got to work out where the hell these damn things are. How are you going to get lucky and find someone's iKettle and actually attack it? It's easy. There you go, that's where they are. Fantastic. That's a scrape from wiggle.net, then output into Google and displayed as .kml. That's actually somewhere on our blog at the moment. But yeah, that's where they all are. It's really easy, isn't it? Bit nuts. The vendor said, yeah, it's fine, it's all right. We've updated it. We've got a new version that shipped about a month ago. So we now have a Wi-Fi coffee machine. I've had so much fun with this thing already. It's great. So, unlike that, which you get boiling water from, so you can only make tea, really, or dodgy coffee. This thing, you hack it, you get coffee. Wired. Brilliant. Bring it on. This is brand new. We haven't really talked about this in public so far. I want to talk you through more serious consequences. So over here, hopefully in my Kali distro, I have. Good. Now, we know what to do with machines like this, don't we? What we need to do is we need to go and get the mobile app, and we need to reverse engineer it, and we need to have a little look. And that is the mobile application. That's the smarter mobile app that drives their Kettle 2.0. Really? How can you have a 2.0? Anyway, whatever. And a coffee machine. The same one drives it. So we took this apart and had a bit of a look. And it's a completely different application, completely different way of working, and really interesting to play with, because it really challenged us. And the first thing we noticed is there's no crazy interfaces like the previous one. There's much better authentication, which we like that. But what we did discover is the mobile app drives it using a simple binary protocol. And that's great, because we can sit there and start doing stuff. And what I've highlighted up there is it's passing the numbers 13 and 126. Now, I don't know if you remember your ASCII off the top of your head, but 13 is a carriage return. Decimal 13 is an ASCII carriage return. That's interesting. All right, what about how do we connect to it? So again, back to the device. And we discover it sets up UDP and also TCP on port 2081. It's all written in the mobile app code for us. Fantastic. OK, so let's have a think about seeing about talking coffee machine. So I've set it up there. We're talking as an access point. It's fantastic. Hopefully this is going to connect. There you go. Great. Now that is actually a status message, you see. So we're now talking to the coffee machine. We went through the mobile application and started looking for all these decimal numbers that's converting into ASCII codes to see how it was working. And we started fuzzing, so just sending any old traffic, sending a bunch of ASCII to see what happened to it. And we found a few bits and pieces along the way. The first one, which was, got me really interested, was that J, that's easier to do at the terminal as letter J rather than typing the ASCII equivalent. Don't know if you can see just there, AT plus GMR. That's everything we need to know. That is absolutely fantastic, because what that means is we have now found an ESP8266. Get in. Google found me that. Fantastic. And AT plus GMR is the command to get it to disclose its firmware version. Awesome. And there's the rest of the command set that I'm going to need to use. So what we had to do is work out how to correlate these commands, how they're being called through the ESP8266 through the Telnet interface. And we found all sorts of crazy bits and pieces going on. What was the real one we wanted to get to was to see if we could get it to make some coffee. And discovered you just send it decimal 7. Let's have a go. Excellent. There you go. So you can drive past someone's house if they haven't got around to configuring one of these things, and you can set it wasting all the coffee beans, making hot water, wasting the power, and all sorts of crazy stuff. Could we cause a denial of coffee? You could. Actually, what you do is you send it into a firmware update loop by sending it the letter M, and it now goes, And I think it's now gone to there you go. It's now trying to update, and it's stuffed. It's not going to do anything else now. That's that part of the demo over, which is all good fun. We like a bit of that. Now, the place we want to go next, and the bit we haven't managed to complete in the research yet, was to actually figure out how to retrieve the user's pre-shared key from this. And you can see the command for that is AT plus CWSAP, which will allow us to query that. We've found the command to retrieve the SSID. We haven't found the command to retrieve the pre-shared key yet. But we'll be publishing that the minute we know, because the coffee machine manufacturers will not talk to us. Don't you love that? Don't you just love that? So we've got the Kettle 2.0 as well. That's back in the office being reverse engineered right now. There's some other interfaces. I don't know if you can really see them, but just up here, you can just about make up there, there are two interesting ports. One believed to be UART, one believed to be I2C. We'll come back to that. Anyway, other crazy stuff we've been looking at rather than just making coffee. These are my ski goggles. They're head-up display ski goggles. Anyone seen these yet? They're fantastic. They have a little screen in them just down there. And it does things like show you speed, which is great for a speed freak like me. So you're sitting there looking down instead of looking where you're going. Always good. Fantastic. But what we discovered, They run Android. They run quite an early version of Android. Lots of vulnerabilities with it. Complete with a USB port with Android Debug Bridge enabled. Get in, fantastic. We haven't managed to do too much to these, other you can actually track the user by Wi-Fi and Bluetooth. And we've mooted actually getting a drive-by attack where you pop up pornography on this little screen and see if you can make the wearer crash. We'll come back to that. That's another one for another time. Now, some of you might have seen my special friend Kayla. And I want to give you a bit of an update about Kayla. This is Kayla. Anyone seen her? She was on the BBC quite extensively, got slash-dotted. Awesome, fantastic. She's been updated. She now has a new dress. This is Princess Kayla. She is fantastic. Now, we want to just have a bit of a look at her. She's an interactive doll that your child can talk to. She'll interact with it. It can respond. It's quite cool. And it's got a great, it says, child safe on it. So, of course, that was a red rag to a bull like me. I wanted to know, could I make her swear? Which, of course, is the objective of anyone messing around with a kid's doll. Now, how do you do it? Well, there's lots of simple things you can do. The way we looked at it, we started looking for hardware issues and looking at the firmware on the doll itself. We started taking her apart, see what we could do. We then routed the phone that was running the mobile app on to see what you could do there. But it was actually a shed load easier than that. The big fail that the manufacturer had made is when it talks to the mobile application to do voice processing, it talks to them over Bluetooth. And there's no security over that Bluetooth connection. Unlike your car kit, where you connect and you have to put a pin in, set up the encryption, there is no security in that Bluetooth connection. So you can pair her to your phone and use her as a hands-free headset. Looks a bit weird. As you probably know, it's illegal to put the phone to your ear when you're driving in the UK. I do wonder what the cops would say if you put her... yeah, I don't know. Anyway, she's done. So, the update I wanted to show you for this, there's actually been some new attacks discovered. We found a couple, and there's a really cool guy called Tim Medin who's done some reverse engineering on the Android app, the iOS app, who's also found some problems. Now, it has swearing filters. They're actually down here. They're in a SQLite database that's contained on the mobile application. And if the child says a swear word to the doll, it recognizes the speech and goes, no, go and talk to your mum about that, or something similar. Okay, fine. If she doesn't have an answer to a question locally, she'll go and look it up on the Wikipedia API. And if content comes back that's got swearing in, so for example, if you asked her about Jimmy Savile, you see the word paedophile, she then wouldn't respond. However, we discovered that the local database of questions, which is contained on the mobile application there, are not subject to those swearing filters. So you can just add any content you want, and she will swear like a trooper. We actually since then discovered 2 more attack vectors. The second one, she also has some stories that you can read. So you can actually drop any content into the stories, and because they're on a local mobile app, they're not validated for swearing content, so she will swear. And the guy, Tim, also noticed that some issues you could actually run on the iOS version. You could actually intercept all the traffic coming back from the API and prevent the swearing filters being applied, which I thought was really cool. But it would be rude not to show you that Kayla really does swear. Here she is. Unfortunately, my video recorded on a...
Hello.
Give her a moment.
Hey, calm down, or I will kick the shit out of you.
Yeah, there you go. You can see I'm a big kid, can't you? So, the other major problem we found, again, if you pulled apart the APK, you could see that actually there was no encryption on the calls to the Wikipedia API. It was done over HTTP, and really made me laugh, because about 3 months ago, Wikipedia changed so you could only access the API over HTTPS. So they broke the doll by applying security. Fantastic. Now, we gave this to the manufacturer quite some time ago, and we said there's a few things you need to do. You know, SSL would be a really, really good idea, ideally before Google enforce it. And they said they put out some updates. And the update they put out was actually, they decided to implement SQL Cipher, which is to encrypt the database on the mobile phone. So it's encrypted, so you can't get access to it, so you can't modify it, so you can't make a swear anymore. Unfortunately, once we pulled apart the next version of the mobile app, which is this one over here, you can see they've implemented SQL Cipher, but they've implemented it with a static database password contained in the client-side code. What? And that doesn't change. It's not rekeyed, so what you should be doing is every time you set up the application on your phone, you should rekey that database so you get a new encryption key. It's not. It's static. It's the same on every single version of the mobile application. Really? Oh, come on. That's one more step. Oh, dear, oh dear. Yes, so she is swearing all over again. Now, one that's hit the press in the last couple of days is Hello Barbie. Anyone seen the Hello Barbie coverage? Really? Oh, come on. More of you should be on this. You should be researching kids' dolls and security. So much more fun. Anyway, so I ended up having a long chat with the guys behind Hello Barbie about 12 months ago. And it's a company called Toy Toy, a bunch of ex-Disney Pixar guys, really interesting crew. And they'd seen the Kettle work and actually had a completely different approach, which was really, really good, because there was basically nothing really going on in the doll particularly. And all you could do was configure the doll, and then she'd then set up secure communications with a back end in the cloud. A researcher's done something quite interesting. In the last few days, they've reversed Barbie, and they've discovered that you can extract things like the pre-share and a small amount of data from there. But Toy Talk have come back and said, well, actually, that's all stuff that you could get just by using the doll normally. So, however, the researchers have extracted all of their firmware and are working on that right now. So I can't wait to see what happens over the next few days. I've been trying to get hold of her for the past fortnight. Best I can do is 200 quid shipped from the US. Really? For a doll? Oh, come on. I want to research. Some of you also probably saw the work on Samsung smart TVs. Do you remember the TVs that were supposed to be snooping on you, listening to you? Now, we saw that. We thought, that's interesting. And it turns out someone had read the terms of use. So we thought, OK, that's... and what it said in the terms of use was, don't say anything sensitive around your TV. Really? OK, fine. Now, I had a Samsung TV. That's my TV. I got home quite late like that night, found the voice control, made sure it was off, and then the next morning picked up my TV and walked it into the office, much to the annoyance of my wife, but that's another story. And what we discovered, it was actually a whole lot worse than it was made out in the press originally. We discovered, so we actually Wiresharked it, discovered that there's us speaking to the TV, there is the audio of me saying the word Samsung to it, discovered it sends it off to a third party, to Nuance Communications, who are a specialist in voice recognition. There's not enough processing power on the TV to do this locally. They sent it off, brought back the word Samsung in plain text. The whole transaction went through plain text. So we broke that story. Samsung said, OK, we take privacy very seriously. It's all fine. Latest TVs are encrypted. It's all good. So I went down to the local Costco and spent 2,000 quid on the latest TV. I made sure it was the latest we had there. 2,000 quid on a 4K 3D awesome screen. It was really cool, absolutely latest one. We updated the firmware to give them a fair shot and discovered exactly the same was going on. The only thing that was different was the codec. Had a bit of fun. We said to the TV, where do I hide the bodies? To see if NSA or GCHQ were listening, but no one's knocked yet. Who knows? So clearly they were being a little bit loose with the truth there. They have finally fixed it. Unfortunately, is when typically what you use the voice for is for doing a search term or changing stuff from the TV. We Wiresharked it all. It's all encrypted, fantastic. And then we discovered when you talk to the TV, once it pulled back the content and then posted it to do a search of YouTube in plain text. Genius. How did they do that? It is now fixed, finally. And then just to prove how much we love Samsung, we spent some time at DEF CON in the US working on a Samsung smart fridge. We don't have these things over here. There are no smart fridges in the UK that I'm aware of, and I've looked really, really hard. There are lots of them in the US. We had a go at this one. The idea being you can put a screen on the fridge right next to your tablet that's on your work surface or your phone that's in your pocket, but hey, it does things like shared calendars and stuff. So you can have messages, you can set up a Gmail account, you can have a shared calendar, it's really cool. I think it's completely pointless, but anyway. So we started fuzzing the calendar. That is the email address of the fridge. It's still live. You can still email our fridge if you want. And we started sending lots of crazy stuff to it, trying to fuzz it, see what was going on, see how it would react. And it did really, really well. The content was well validated. We really wanted to take the fridge apart, but the guys who got the fridge had it on sale or return from the local Best Buy, so we couldn't take the panels off. Nah. But what we did find was the Gmail account they used to set up the calendar and email on the fridge doesn't encrypt your Gmail password. It doesn't validate the client-side SSL certificate. It sends it over SSL, but doesn't validate the certificate, so you can drive past someone's fridge, do a man-in-the-middle attack over Wi-Fi, and extract the user's password from their fridge. I think that's bonkers. I was going to talk about washing machines, but yeah, that's another story. This one I really do want to talk about. This is, as far as I'm aware, the first internet-connected home device setup in the UK. I saw this come. We had one of the very first ones that was shipping. This is the Hoover Wizard. Anyone seen this gear? It's really cool. You can turn your oven on from your phone. Why? I don't know. It's got a cooker hood you can turn on from your phone, and you can do stuff with your fridge, like make it a little bit colder from your phone. And you can start your washing machine from your phone. But I don't know. I tend to fill my washing machine with clothes first. I don't know. Anyway, train wreck time. I just want to show you this mobile app before I wrap up. This is it over here. First things we found, oh my goodness me, is error reporting was reported out to the application manufacturer, HTTP, and I'm told if you go to that URL, you'll find a bunch of crash reports from people's ovens. That's really bad, really, really bad. The other thing I wanted to just flag to you, I don't think I've got it up here, is rather than using SSL to encrypt the communications between your phone and the device when you're working on the local network, They roll their own encryption, and they have this most amazing encryption algorithm called XOR. What? What? They even call it encryption. They call the class called encryption. They do XOR it with something. They XOR it with the SSID. So that's the one thing that you know when you're outside the house trying to attack it. They XOR it with SSID. That's bananas. Yeah, so we'll let you know how that one goes. I was going to talk about my scales as well. And what I wanted to talk about my scales, my Fitbit scales. This is a great example of a vendor who were really cool about disclosure, by the way. These are my coffee stain scales. Anyone here got a Fitbit? Have I got the audience wrong here? This weighs you too, and it correlates your weight, so it sends your data off over Wi-Fi to Fitbit's servers in the cloud. Quite cool. We pulled it apart, and we discovered a vulnerability which we disclosed to Fitbit privately. They were really cool. We got it to them privately. I wish all vendors would work like this. They worked with us, we explained the vulnerability, they patched it, and after they patched it and everyone was up to date, we got to disclose the vulnerability, and they gave us a bunch of free scales. Next time I'm going to work on cars, but anyway. I'll take some tips about the Tesla next time, please. What I wanted to make the point about this is you've got to remember that one of the big game changers with the Internet of Things is that people have got access to your stuff. It's not like a website where you go to the website and it's all fine, it's all protected by firewalls and application firewalls and stuff. You've got access to all your stuff. Your source code is all on there. So the sort of places you might attack, and this is how we found the vulnerability, incidentally, is you start looking at the interfaces. So you get some logic probes, logic analyzer, and start retrieving stuff. So we found the UART port, which we managed to find user data from, and then the SPI interface, that's how we managed to find the web server that is thrown up during the setup process that discloses your Wi-Fi PSK. If you want to go a bit further, you can also start talking to the JTAG connections. We haven't bothered doing that because, frankly, that device is totally owned now, but it's really cool. Last couple of bits and pieces. I also want to show you my iSpy tank. This is another great example of credentials going wrong. There's a little Wi-Fi access point that you can drive around from a mobile app. Unfortunately, it'll connect to anybody, and a great example of how you can get this stuff really, really bad is my little tank here. It has an interface when you try and connect to it. It's all right, it's got a password. Unfortunately, the password for you to take control of this tank is static in the client-side code. Happy cow. Brilliant. So if you've got one of these in your house, someone can take control of it and start driving around and spying on you. Cool. Other crazy stuff. I spent a little bit of time working in the field of teledildonics. This is quite scary. I feel a bit soiled. This is an internet-enabled dildo. Ugh. But whilst looking at the mobile application, we discovered that you can have chat sessions, apparently. You can control over the other end. But those chat sessions are videoed, and certain of the image files and video files are stored in Android external storage, which is either the removable SD card or emulated external storage that you can access over the USB connection. So if you lose your phone, you've got some real trouble there. The last bit that made me chuckle the most was they have a default Bluetooth pin. So if you do a drive past someone's house and they're pairing, you can take control of their dildo. Ugh. Ugh. Anyway, so really just to wrap up now, I think Internet of Things vendors, and certainly in terms of consumer manufacturers, they've got a lot to learn. I mean, this is a big leap for them, going from making a kettle to making an internet-enabled kettle is a big stretch. I think there's a lot of mobile application coders. We typically find that the development of the mobile apps is outsourced to a third party, and if you don't ask them about security, they'll probably do least cost and do a job that'll just cause a train wreck. It'd have been much harder for us to find those bugs if the code had been properly obfuscated. It would have been much more difficult for us to follow the flow. You could have still done it, which would have taken us longer. So things that you could do, really simple things, if you're looking at a product that's going to market, something that's been brought into your organization, simple things. Pull the code apart. Can you follow it? Is it plain text or is it obfuscated? Is it difficult to follow? Really, really simple thing. It will tell you if the mobile app development house have thought about security. 20% of all the mobile apps we look at have some form of static password, static key in the client-side code. It's asking for trouble. And then a fair proportion of those will be using plain text to do their lookups on their APIs. And if they do SSL, they might well have forgotten to pin the certificates. If you don't do either of those, you're open to a man-in-the-middle attack over Wi-Fi. Horrific. I'd just leave you with one thought. There are a lot of people researching a lot of things in IoT devices right now. You are going to get a call from a researcher at some point, whether it's me or one of the many other researchers out there who are doing some really good stuff. If someone talks to you, make sure you've got a process for engaging with them. The fact they're talking to you is a good thing. Engage with them, talk to them, find out what they've got to say. If you've got a bug bounty program, even better. particularly if it's a Tesla. Get in. But please, engage. I blog about this every day. That's my blog. You can follow me on Twitter. The blog's there as well. If you've got any questions, I'll be around at lunch. Hope you found it interesting. Thank you.